Hi, this is Christopher Boucher, and I'm going to demonstrate solving an example with a 95% confidence interval. Okay, so we start off here. I'll go to the question. Construct a 95% confidence interval for a sample mean of 70, population standard deviation of 10, and a sample size of 60. So let's write out what we know. Let's see, sample size is 60. And then our sample mean is 70. And our population standard deviation is 10. Okay, so let's write out what we know first. And we do this so that we can, we write out what we know about the information provided so that we can figure out what type of distribution we're going to use. So known standard deviation, population standard deviation, sigma, and our n is greater than or equal to 30. So what that tells us is we're going to therefore use the standard normal distribution with a z-score. So z distribution. So we're using the z distribution. That makes it easy on us, right? So the next thing is we need to figure out what the value is for the 95% confidence interval. It's a pretty common value. So we go to our table. This is an alternative z-score table. It's not cumulative. It's essentially one side. So we go to the 95 value here. I've written in the colored parts, 95%, and we end up getting this value right here. Now this is the area under the curve for one side. We're not concerned with that in this problem. What we want is the z-score. So the z-score ends up being a little hard to see, but it's 1.9, and then we go up, a little reflection off of this, it's 0.06, so it's 1.96, so 1.96. So this is our critical 1.96. This is our cutoff for if we're doing hypothesis testing. This would be our critical value here, but we're just doing a confidence interval, so that's fine. Okay, so let's go and solve the rest of this. Okay, let's see. So for the confidence interval, we're going to do this. We use a formula that is like this. And it's because we have a sample, we don't have perfect data. So we are using this formula for solving. One side is going to be negative, one positive, which gives us the range or the confidence interval. So, okay, it's easier when we do this to calculate this first. So we'll do that. For us, we have a population standard deviation, or sigma, of 10. And then we have a sample size of 60. So that's the root of 60. And when we work that out on our calculator, it ends up being 1.290. We could go out further, but for this we don't need to. So it's 1.290. Okay, so let's go and set up our ranges. I'll scoot up. First we'll do negative, so we end up with the sample standard deviation. So we go 70, negative, and then we will look at the z value, which is 1.96 multiplied by our value right here, our essentially standard error, but it's the standard deviation of the sampling distribution, but it's also considered the standard error, and that is 1.290. And then on the same note, we do this. We do 70 plus 1.96, 1.290. So that's our positive and negative range. And the values already have calculated out, and it is 67.469. Oh, my 9 didn't look too good, but that's a 9 right there. And then the positive is 72.530. So about 67.46 to 72.53. Okay, let's work this out now on the calculator. Make sure we're right. I'll zoom in for this. So on the calculator, we're going to do this. I'll turn off the light so it's easier to see. Okay, on the calculator, we go to Stat, then go over to Tests. And if we can go down, actually it's easier going down in this case. And it's in this case on the TI-84 plus CE, it is the number 7 option. It might be a little different depending upon which version of Texas Instruments you're using. Okay, so I have it set up for stats. It's flashing for stats, but we could use a data list if we wanted to. But in this case, we just want to put in the information. So I go down, and our standard deviation was, our population standard deviation is 10. It's already in there. Our sample mean is 70. And our sample size is 60. And it says C level, that's our confidence interval or confidence level, and that's already set up for 0.95. And now I hit calculate. I've been clicking the down button to go down. And we end up with, let's see, 67.47 and 72.53, which should be very close to what we received here. So 67.47, so it rounded, which is interesting. Usually calculator doesn't do that. But in this case, the output's down to the 2 decimal places. And then for the upper side of this interval, it said I calculated 72.53, and it was 72.53. So it matches up. So I hope you learned a little bit about confidence intervals with a Z distribution. Thank you.